Okay, now before you start this question, please reset timer. And then, and then you need to explain to me how you solve this question, and then you can code it up. Finally, you need to tell me the time capacity and the space capacity. Okay, let's do it.
Sure. Are you recording?
Yeah. Yeah.
Okay. Solve LeetCode 200, number of islands. This is a grid question where we're dealing with a list of lists, as you can see. So a matrix is essentially a list of lists. So you have rows and you have columns, which are basically nested within the rows. So that's important to remember. Given an m by x 2D binary grid, which represents a map of ones, counted as land, and zeros, counted as water, it's important to note that ones and zeros are strings here, not integers. A lot of people get that wrong. Return the frequency of islands at the end. An island is surrounded by water, aka zeros, and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So what this means is that if we can visit the same cell, aka 1 as a string, land, horizontally or vertically, we don't want to double count the island. So this is one island. Why? Because they're all connected either up or down. If we had a 1 here, then we'd have two islands. If we added a 1 here, we'd have two islands. Right? So diagonals do not count as the same island. So we really want to make sure that's important and done. So what we want to do is loop through the rows and the columns of the grid. See if we see a 1. If we see a 1, we can go into our depth first search, which explores this particular direction at a time before backtracking so that we don't double count the same islands. As long as we see a 1 in either 1-4 directions, we do not increment our account variable. And we do this every single time for every single cell, every time we see a 1. And we mark the 1 as visited. So if I draw a picture here, let's take the input here. So we're going to loop through the array, and we're going to see this 1. Because we see a 1, we already know that we have at least one island. Then we're going to do a DFS this way. Then we're going to do a DFS this way. We're going to do a DFS this way. And then we're going to do a DFS this way. We're going to see all the 1s. And we're actually going to flip the 1 into a visited.
Okay.
We're going to turn the 1 into a 0.
Okay.
Because we're using the 1 as an indication that it's part of the same island. Because if we see a 0, we're not going to count it as part of the same island.
Mm-hmm.
So we're going to do this for every single 1 we visit. For example, 0, 0, 0 means that this one direction counts as one island.
Mm-hmm.
Then when we backtrack, we're going to reset it. We're going to do the same thing here. 0, 0.
You don't need to reset it. You don't need to reset it because this
we will reset it, because if we don't reset it, then
because you just
we're going to run into some problems down the line. But the way it works is that's the basic idea, and we're going to loop through and we're going to do this. But in terms of resetting, we're actually are going to reset, because in the future, when we reach it, we want to see the same island, because if this is a 0, then we're not going to count it as the same island. So for example, if we don't reset it,
you just 1, right? The number of island. The number island just 1, right?
Yeah, it is just 1.
Even though you didn't reset it, it's fine.
Oh yeah, we do not reset it, because we're going to see a 0 and we're going to say that's not part of this. That's not an island at all. Okay, you're right.
Yeah.
Okay. Yes, so you see the output's 1 here. The output 3 here is 3, because support by grid is one island. This is another island. This is another island. Okay.
Mm-hmm. 3, yeah.
So we're going to have a count variable first. We're going to loop through the coordinates of the grid. And again, as we said, if we see a 1 as a string, important, then we're going to go into our DFS.
Mm-hmm.
Cool. So we have to do our boundary check, which is always going to be true in the first iteration. So we're going to check if we're going out of bounds. Rows for columns, or grid row of column is equal to 0, then we're just going to return out of that function call. That's not the case, then we can flip it. We know that we see a 1 and that we're in bounds, so we can turn it into a 0. And we can do the same thing in all 4 directions.
Okay, you go up, go left, go right, go down, right?
Yeah, so row -1 column. Yeah. So row -1 is going
Go up.
up
Yeah,
because we're coming back from where we came from. Row column -1 is going to the left because we go right.
Mm-hmm.
Row +1 column is going down. Column +1 is going to the right.
Mm-hmm.
And at the end, we can just return the count. It should be correct.
Oh,
there you go.
Okay. Here we go.
There you go.
Okay. So can you talk about the time
complexity and the space complexity are, I believe the time complexity here is O of n, because it's O of 2n, because we're looping through the rows and looping through the columns. And then we're going to this DFS here where we have to backtrack from every single cell. So it's O of 2 of n, I believe. I'm not sure if that's correct or not.
Not when, right? It's n times m. N is the row.
M times m. Okay,
yeah,
okay.
Yeah.
So O of m times m, yeah. I'm not too clear on that.
Yeah.
And the space complexity should be O of 1. We're not storing anything extra here. We have a nice variable, but that's not valid at all. We have a DFS function call here that doesn't take extra space.
Okay. Sound good? Okay, thank you. You explain me this question.